Hello, today we are starting with the IGCSE from Tuesday the 21st of May 2019. So it's paper references 4MA1, 1H. As ever, we have the formula sheet. Now let's start. So this show that 4 2/3 divided by 1 1/9 equals 4 1/4. So this is a show that, so ignore the answer. Basically, pretend you don't know that. What you're going to do is start off by making improper fractions. Okay. So you're going to do that by going 4 times 3 is 12. So that's 14/3. And 1 times 9 is 9. So that's 10/9. Okay, now we're going to use the keep flip change, which means keep the first one. So we keep 14/3. We change the divide to a times and we put 9/10. So we do the reciprocal. And then on the bottom, we're going to get 30. And on the top, we're going to get 14 times 9, which is 126. Now we need to change that into that somehow. So firstly, we're going to divide 30 into 126. And that gives us 30 into 126 gives us 4 rem 6. So what we've got is 4, and then we've got 6/30. And 6/30 can be simplified to 1/5. And that means we have solved it. So we did the left-hand side, and eventually we got the right-hand side, if we're going for a proper proof. Okay, let's go to question number 2. Question number 2 is about Jelena, who left her home at 10 to cycle to a park. On her way to the park, she stopped at a friend's house, so that will be when she's not moving. And it's the distance time graph for her journey. Now, you can get distance, you could get speed, and you could get acceleration graphs. I don't think you do get acceleration graphs in maths at GCSE, but this one is a distance one. So on the journey to her friend's house, did Jelena cycle at a faster speed before or after she stopped at her friend's house? So what they're basically saying is which of these lines, this one to this one, or this one to this one, is steeper. And for that, she did 15 kilometres in an hour. So 15 in 1. And for this one, she did 9 kilometres. So it's 24 to 15. So 9 kilometres in, I think, 45 minutes, so 0.75. So that is, let's just check that 9/0.75 isn't bigger, but I don't think it is, it's 12. Right, so that means that the before is the answer because it's steeper, or it's got a greater gradient. Because we find the gradient by doing rise over run. Okay, Jelena stayed at the park for 45 minutes. She then cycled without stopping at a constant speed of 16 kilometres per hour from the park back to her home. Show this information on the distance time graph. Okay, so 45 minutes, it's now 12, and we need to go until 12:45. And then she's going at 16 kilometres per hour home. So 16 kilometres per hour will mean that she's got to go 24. She's going 24 kilometres. So that's going to take, if we divide that by 16, that gives us 1.5. So it's going to take her 1.5 hours to get home at a constant speed. So from 12:45, that means we go to 1:45, that's there, and then we add 30, so we're expecting her to be home at that time. And all we do now is we take our graph take our ruler and we plot that. So that should be, she gets back at 14:15 or 2:15, and this means at the top that she's rested or at least not moved for 45 minutes. Okay, so we've done that. Work out Jelina's average cycling speed in kilometres per hour for the complete journey to the park and back. Do not include the times when she was not cycling in your calculation. Give your answer correct to 1 decimal place. So we know that she went 24 kilometres from, so we know she did 15 in 1 hour. We know she did 9 in 0.75, and then she did 16 kilometres, or rather she did 24 in 1.5. So we'll add all of the times and all of the distances together. So we know the speed equals distance over time, because we always say things like kilometres per hour or metres per second. And our distance is going to be 15 plus 9 plus 24. And that's in kilometres. And our time is going to be, now this is a little bit, I'm kind of being a bit weird because I'm doing this in parts of an hour, and we don't normally refer to them in this way. We'd normally say 1 hour, 30 minutes, 1 hour and a half, but I'm doing it in decimals. So it's 1 plus 1.5 plus 0.75. Okay, so that's 1 plus 0.5, 1.5 even, plus 0.75. So on the top we get 39.48, which makes sense, it's 48, 24 times 2. And on the bottom we get 1, 2.5, 3.25. You can check these things on a calculator. And then this should be under 16 kilometres per hour. So let's do 48 divided by 3.25 equals, what am I giving this to? 1 decimal place. So we got 14.769, so we're going to go 14.8. Which makes quite a lot of sense because she did cycle around that speed for most of the time. So if you get something that comes around the same point, you're like, yeah, this is great. Simplify e to the power 9 divided by e to the 5. I always write things like this because I find them easier to read. When you do this, it literally means if you've got the same base, you just take the indices away. So it means e 9 minus 5, and that would be e to the 4. With this, with b, y to the 2 to the 8, that means times the indices together. So it's y2 times 8, and that's y to the 16. And expand and simplify. You can do this by using the FOIL method, the claw method, whatever you like, but I prefer this because I think it's more elegant. And also you can sort of see what you're doing. X plus 9, x minus 2, so that's x squared, plus 9x, minus 2x, minus 18. Write them out and simplify. X squared plus 9x, minus 2x, minus 18, and that's x squared plus 7x minus 18. That goes into there. Maybe just put something around it so they know. And this is factorised fully. Now when it says factorised fully, it means that you know that you can take out the number at the beginning, but you may be a bit lazy and take out less. So the number at the beginning, the thing that 16 and 20 have in common is 4. The thing that c to the 4 and c have in common is just c. The thing that p squared and p cubed have in common is p squared. Now, what they're asking is what do we times this by, p, 4cp squared, to get this and then this one. So you would times 4cp squared times 4, c to the 3, and that's it, because you've already got the p squared. And then we add 5, and we've already got the c, so we add p. And that is our answer that goes in there. that doesn't require an awful lot of steps, does it? Right, there we go. Okay, complete the table for this. See, whenever I see one of these, I always start off by using the 0. I'm quite inclined to go for a different colour now. Okay, so let's start off with the -2. So all you're doing is you're taking this number and you're subbing it into there. So we'll start off with y equals -2 squared minus 3 times -2 minus 1. Now that's a lot of minuses. There's so much potential to go wrong here. And so that will equal 4. So -2 times -2 is 4. Remember, if you hate to hate, you love. -3 times -2 is +6. And -1 is, that's 9. Okay, so we get 9 in there. I'm also going to take this away. I'm going to take that away, but very badly. I don't love what I've just done there. Okay, so now we've got, excuse me, -1 squared minus 3 times -1 minus 1. Okay, so that's -1 squared is 1, -3 minus 1 is +3 minus 1, so that's going to be 3, isn't it? You can tell because there's a balancing out. Then we've got -1, which makes sense because if you put the 0 in, that's great. Then we go, let's get rid of that. And let's get rid of this. So then it goes -1 squared, 1 squared is 1, -3 minus 1, so that's -3. And then that's -3 again. Now weirdly, I know this is going to be -1 because it's going, it's symmetrical around whatever this point would be there, 1.5 I'm assuming. So we will now do this one. So 3 should give us -1, otherwise, you know, we all make mistakes. 3 squared minus 3 times 3 minus 1. So that's 9. Minus 9 minus 1 is -1. Okay, so we've done that, and now they want us to draw it in. So let's always be careful with the scale on these things because they tend to be a little all over the place. So -2 is 9, -1 is 3, 0 is -1. Let's just do that. Then we go to 1, which is -3. It's slightly irritating to do. And then we go to 2, which is -3. That means it's sort of subbed out around there. Then we go to 3, which is -1. And then we go to 4, which is 3. And then we draw it smoothly in. Now, I may not be drawing that smoothly. I mean, that was not beautiful, but it'll do.